A, C, and E, the ones highlighted in yellow, fall below the decision rule of 12 for the coverage benchmark of 75%. There is one supervision area that we can say it is above the average coverage, and it is above the benchmark. That is supervision area B, as the correct number of answers found in this supervision area, and for this particular indicator, is higher than 6 or higher or equal than 12 respectively. This is the supervision area that should not need any additional intervention, but rather to maintain the strategy being implemented. In addition, this is the supervision area from which others can learn from, either from the project staff working in supervision area B, or from health workers and partners staff working in there as well. As you can see from this example, we're looking at just one indicator for all supervision areas. And while we calculated an average coverage for the entire catchment area, that is the aggregation of all supervision areas, we did not calculate coverage rates for individual supervision areas. Rather, we relied on the coverage for the entire catchment area, either the average coverage or the benchmark, in order to identify a decision rule, which helped us to identify which supervision areas are above or below the average coverage and which ones are above or below the benchmark. The same analysis can be done for as many indicators we want to calculate, as long as we have collected the required data for their calculation. This summary table shows 5 indicators used by our project in one supervision area, that is supervision area D. For this particular example, this project includes interventions like maternal and newborn care, case management of diarrhea and ARI cases, immunization, and malaria control. For each of these interventions, we may have at least one indicator. So what this table is presenting is the performance of supervision area D reflected by 5 particular indicators. Can you identify indicators that are going to be our priorities? You bet. Those will be indicators number 1, delivery is attended by a clinically trained provider, and indicator number 3, sick children between the age of 0 to 23 months who received increased fluids and continued feeding during an illness in the last 2 weeks preceding the survey. As you can see, LQAS flags where the problems are in terms of specific indicators. The same analysis can be done not just for one supervision area, D, but for all supervision areas defined in our project catchment area. This summary table is showing us which supervision areas appear to be performing the best for all 5 indicators. Those will be supervision area E, and maybe supervision area A. These are the supervision areas that we would probably visit to learn possible ways to improve with our indicators in the rest of the supervision areas. This table is also telling us which supervision areas appear to need the most support for their overall program. Those will be supervision area B, supervision area D, and maybe supervision area C. These are the supervision areas that will need a special attention. We can also tell which indicators need improvement across most of the catchment area. Those will be definitely indicator number 3. There are 4 supervision areas that are weak for indicator number 3. And indicator number 1, as there are 3 supervision areas that are weak for indicator number 1. This table is also telling us which indicators need improvement in only a few supervision areas. Those are the indicator number 2 and the indicator number 5. Once again, you can see that LQAS flags where the problems are in terms of specific indicators, and what supervision areas deserve more resources. Now, after seeing all these numbers and tables, you may wonder, why does this LQAS table for decision rules have so many different sample sizes if we are using a sample of 19 per supervision area in all these examples? Well, in real-life projects, we will not always obtain 19 observations as the sample size for a specific indicator in a supervision area. This is life in the field. And for this reason, the LQAS table for decision rules is designed to take into account these contingencies. This will be the case of those indicators that apply to certain population subgroups. For instance, complete immunization coverage is calculated only for those children between 12 to 23 months of age, or the exclusive breastfeeding rate for children under 6 months of age, and a few more other indicators as well. So in some of these cases, we will not always be able to collect 19 observations for all questions we ask in our surveys. And for this reason, some supervision areas will have different decision rules as different sample sizes are used. As we reduce the sample size from 19, we will incur into some trade-offs in terms of sensitivity and specificity. But in some cases, we could still analyze results at the supervision area level, while in others, we would need to aggregate data from all supervision areas and do the analysis for the entire catchment area. We will look into these cases in lectures numbers 2 and 4, and we will discuss different techniques to minimize the potential of small sample sizes, but this will be a subject of further explanations in those later lectures. Here is another example that happens quite often in real life. As you can see from this table, the sample size may not always be 19 per supervision area. When this happens, we will need to calculate decision rules for each supervision area. In this example, the average coverage is 48.4%. And with this information, we can go back to the LQAS table and identify decision rules for each supervision area for the corresponding sample sizes. In lectures numbers 2 and 4, we will address the implications of having smaller sample sizes than 19. And we will also address issues like parallel sampling, when sample sizes for some indicators may be greater than 19 and sometimes as great as 38, for which we will work with LQAS tables that cover this type of larger sample sizes. For now, we want to highlight for you what a sample of 19 can tell us, and this can be summarized as follows. A sample of 19 is good for deciding what are the higher performing supervision areas to learn from. And it is also good for deciding what are the lower performing supervision areas. A sample of 19 is also good for differentiating knowledge and practices that have high coverage from those of low coverage. And it's also good for setting priorities within a supervision area. And finally, it's also good for setting priorities among supervision areas with large differences in coverage. We would also like to bring up to your attention what a sample of 19 cannot tell us. Such a small sample is not good for calculating the value of the coverage in a supervision area, but can be used to calculate coverage for the entire program. Also, a sample of 19 is not good for setting priorities among supervision areas with little difference in coverage. As for why using a small sample of 19, well, a sample of 19 keeps us an acceptable level of error, mostly less than 10% for making management decisions. And also, such a sample of 19 is practical for the type of decisions that we want to make. If we want to increase the precision of results from a survey using LQAS, we would need to significantly increase the sample size.